Cryptarithm puzzles originated in the 19th century. The earliest known example was created by Auguste de Morgan in 1845, a famous mathematician who loved creating problems that challenged logical thinking. During that time, these puzzles were mainly used for entertainment. They appeared in math books and magazines as a fun brain teasers. Later on, in 1924, Henry Ernest Dieudonné, another well-known puzzle creator, helped make cryptarithms even more popular through his books, named Amusement in Mathematics. His work introduced cryptarithm to a wider audience and showed how enjoyable and thought-provoking they could be. Then, in 1931, Maurice Krejcik officially introduced the term cryptarithm. This came from the word crypto, meaning hidden, and arithmos, meaning number, literally translating to hidden numbers. A few years later, Derek Norman Lemmer coined the term alphametic, which refers to cryptarithms that form real words or meaningful phrases using letters. Over time, cryptarithms evolved from simple puzzles into powerful educational tools. Teachers and mathematicians began using them to help students enhance their logical reasoning, problem solving, and analytical thinking.
The problem statement explains what a cryptarithm is. It says that a cryptarithm is a mathematical puzzle where letters are used instead of numbers. In a arithmetic problem like addition or subtraction, the goal is to find out which number each letter stands for from 0 to 9, so that when you replace the letters with the correct digits, the entire equation becomes mathematically correct. For example, in a puzzle like send plus more equals money, every letter represents a different number and your task is to figure out those numbers using logic, reasoning, and basic math rules. In short, the problem statement means that cryptarithm help us think logically and solve problems step by step.
So here's the folio's 4 steps. First, understanding the problem. The cryptarithm's objective is to determine which number each letter stands for in order to solve the equation correctly, enabling problem solver to improve their analytical and reasoning skills. The goal of the cryptarithm is to find which number each letter represents to make the equation correct, allowing the puzzle solver to enhance their reasoning and analytical ability. Second, devising a plan. In solving cryptarithm, I would mostly use pure logic and small amount of arithmetic to determine what the letter represents. I begin by breaking down the layout of the puzzle, then use rule of addition or subtraction, having nothing more than two letters be assigned the same number. Through checking carries, testing values, and spotting patterns, I find the correct solution, carrying out the plan. To solve 1 plus 2 plus 6 equals 9, each column is analyzed as an equation. From the unit column, O plus X equals 10, giving a carry of 1. The 10 column gives W equals T plus 1 equals 9. And the 100 column give I equals O plus T plus S minus 9, with the leftmost carry equal to N equal 1. By testing possible values, choosing O equals 3, T equals 2, and S equals 8 gives I equals 4, W equals 5, X equals 7, and E equals 0. U 310 plus 253 plus 847 equals 1410, which satisfies the equation. Thus, this solution is 0 equals 3, N equals 1, E equals 0, T equals 2, W equals 5, S equals 8, I equals 4, X equals 7. Looking back, solving cryptarithm taught us how to think logical and carefully analyzing patterns in numbers. We realized that mathematics is not just computation, but also creativity, logic, problem solving that can be applied in real-life situations like coding and cryptography.
So let's talk about key solution highlights and mathematical relationship of cryptarithm. A cryptarithm is a mathematical puzzle where letters replace digits in an arithmetic equation, challenging solvers to decode the original numerical sum. It is the task of logical reasoning. and arithmetical principles, governed by key constraints. Each letter represents a unique digit 0 to 9, and no multi-digit number can have a leading 0. Solving a cryptarithm is not merely a process of trial and error, but a deductive exercise built on mathematical relationships, where it is based on value, modular arithmetic, and properties of numbers. Let's talk about key solution highlights. There are 5, which is unique mapping. Each letter corresponds to one unique digit. The same letter must always represent the same digit. No leading zeros means the first letter of any multi-digit number cannot be 0. In logical deduction, many clues can be found by analyzing the puzzle structure. For example, in an addition problem, if the sum has one more digit than the numbers being added, that leading digit must be 1. Trial and error means that when direct deduction are exhausted, intelligent trial and error can, because this process is more efficient when combined with logical reasoning that has a smaller set of possibilities. In systematic approach, solving by hand often involves rewriting the problem to align the place values and tracking potential values for each letter. Let's talk about mathematical relationship. There are 3, which is the place value expansion. The letters are expanded into their place value components. Carryovers, the m in money must be 1, as it represents a carryover adding 2 single-digit numbers, while in properties of parity, looking at the odd or even nature of digits can provide clues.
Now let's move on to our understanding about cryptarithm. We explored the interesting world of cryptarithms. At first, it looked confusing because the numbers were replaced by letters. But as we started solving, we realized it's like cracking hidden code using logic and math. In a cryptarithm, each letter represents a unique number, and our goal is to make the equation correct. To solve it, we followed following 4 steps. We first understood the problem, then made a plan by identifying patterns and possible digits. After that, we tested our ideas and finally checked if our answers met all the conditions. It took time and teamwork, but once the equations balanced, it felt really satisfying. Through this activity, we learned that problem-solving math is not just about getting the answer, but about using reasoning, creativity, and patience. Sometimes we failed, but each mistake helped us understand the problem better. This experience taught us that math can be both challenging and enjoyable. It helps sharpen our thinking, builds teamwork, and remind us that every problem has a solution when we stay determined and work together. In the end, solving a cryptarithm showed us that learning math is not just about numbers. It's about developing our minds and learning how to think critically.